Okay. Today we will discuss about wind energy and how we can obtain electricity from wind energy. The wind energy that is used to produce electricity by converting the kinetic energy of air in motion. Okay, that kinetic energy that is being converted into electricity means we need wind. So air that is in motion, so it is wind, and that energy that is converted into electrical energy. So in modern wind turbines, the wind rotates the rotor blades, which convert kinetic energy into rotational energy. Okay, this rotational energy can be transferred by a shaft to the generator, thereby producing electrical energy. How it is working? The wind, which is uh, having a kinetic energy that is being transferred to the blades, the rotor blades that is connected to the generator via the shaft, and that generator is producing electrical energy. So it is converting kinetic energy, that is a form of mechanical energy, into electrical energy. So this is not the only um, function or the application of wind energy. We can use it in other task as well. Just we will discuss it shortly. Okay, so wind turbines, they convert kinetic energy into the wind, in the wind into mechanical power. Okay, this is one part. Then this mechanical power can be used for different type of task, not only producing electricity. Okay, it could be used for grinding grain or for pumping water. Okay, or this energy can be transferred to a generator, and the generator can convert this mechanical power into electricity. So the working of wind turbine, that is opposite to that of a fan. So in fan, what is happening? The electricity that is being supplied, and that is being converted into mechanical energy, which is available at the wings or the blades of the fan. Now here, instead of using electricity to make wind, the wind turbines use the wind energy to make electricity. Means the operation, the working, that is absolute reverse. Wind energy is available, and using that we are producing electricity. The wind turns the blades, which spin a shaft, which is connected to a generator, and we are getting electricity. The energy in the wind turns 2 or 3 propeller like blades. They are around a rotor. The rotor is connected to the main shaft, which spins a generator to create electricity. So wind turbines are mounted on a tower to capture the most energy. Okay, that is why usually we try to give it height. Okay, so at approximately 100 feet or 30 meters above the ground, they can take advantage of faster and less turbulent wind. Means height is a big factor. The amount of energy which can be extracted from the wind or which can be utilized depends on the height. So this is the diagram of a wind turbine system. So here on the top of this pole, so the rotor is there and blades are attached there. Through this, the shaft and gearbox assembly, the generator is connected. Generator is there at the top. There is a controller, and through the generator, the electricity that is being produced, and that electricity is being uh, taken out, or we have extracted it, that we are utilizing it. Okay, another thing, yaw drive. A part shown here is the yaw drive. So that is usually made to adjust the position of the turbine. Okay, so that the maximum wind cuts the blades and maximum energy is obtained. Now how wind turbine works? So energy in the wind turbine, energy in the wind turns the propeller like blades around a rotor. The pitch of the blade makes optimum use of the wind direction. The rotor is connected to the main drive shaft, which means a generator to create electricity. Then wind turbines are mounted on a tower to capture the most energy. So approximately 30 meters or above. So we need to give a height to the system. So wind turbines can be used to produce electricity for a single home or a building, or they can be connected to electricity grid for more widespread electricity distribution. Means low to large scale production we can do using this wind turbine. So advantages, first one, no pollution. Yes, it is a clean source. Then low prices. Okay, this is a renewable energy. Time and again we can get, and it is having a low price. Another advantage is that it does not produce any type of emissions in the atmosphere that can cause acid rain or greenhouse effect. Now coming to disadvantages, so depending on how energetic a wind site is, the wind farm may or may not be cost competitive. Means it is site specific. Anywhere we cannot install it. A suitable site is needed. The wind turbine cannot be, wind energy cannot be stored. For storing, we need another storage medium, like the batteries. Okay, next disadvantage is that good wind sites are often located in remote areas. Consumption is not there. They are remote areas, very less consumption. But the scope for maximum generation, that is there. So that is at a large distance from where the consumption is, or bulk consumption is. Okay, next disadvantage is that wind resource development may compete with other uses for the land, and those alternative uses may be more wihighly valued than electricity generation. Means land which is being used for wind farm, wind energy farm, that land can be used for some other purposes as well, other valuable purposes as well. That is another challenge. Okay, one more disadvantage is from the birds, because the rotors, they are having blades, and the birds, they can be killed by the movement of these rotor blades. Now, two type of these wind farms, offshore and onshore. So the diagram gives a clear difference. So the offshore, that is inside the water body or the sea. Now, India, the southern area, that is having a good scope for this offshore wind farm. Okay, onshore is also there. We will just discuss shortly. So onshore, that is on the land, near the shore. Okay, now advantages of onshore wind farm. The regular onshore turbine lasts for around 20 years. Second, normally it takes about 2 to 3 months before the wind turbine has paid itself back. So that includes energy, so which were used to produce, install, maintain, and remove the wind turbine. Okay, next, cheaper foundation. Yes, this will be a big advantage as compared with offshore wind turbine. The foundation, that is very cheap. So cheaper integration with grid network. Okay, interconnection with the other generation plants. So that is very easily we can integrate it. Now coming to disadvantage, so wind turbines, they are noisy. A lot of noise is being produced. Then another disadvantage is large wind turbines can make unpleasant view of the landscape. Here the land where it is installed, that the view, that is not much pleasant. Now coming to the another type, the offshore wind farm. So offshore wind turbine, that is stronger than a onshore turbine. So it lasts about 25 to 30 years and produce 50% more energy than a onshore turbine. So when a strong wind blows, it produces about 3 to 5 megawatt per hour. So a large amount of energy we can obtain from offshore wind farm. Okay, higher or more constant wind turbines. Wind speed, sorry. Wind speed, that is constant with more height. Now coming to this disadvantage, so they are much expensive to build because the foundation is within the water, within the sea, we can say. There we have to build it, the foundation. Next one is more difficult to maintain and access. Yes, because they are not on the land. So we have to, for maintenance and accessing the site, we have to go there, the water body. So this one is the India's largest Mupandal wind farm. It is in Kanyakumari in Tamil Nadu. So it has an installed capacity of 1,500 megawatt. Again, 3,000 turbines are there. So it is world's third largest operational onshore wind farm. It is onshore. Now wind velocity with height. So here directly we can see in meters on the x-axis, in the meters, the height is given, and on the y-axis the wind speed increase factor. So directly the speed is increasing with height. Now power output with wind speed. The speed that is given on the x-axis, meters per second, then output in power. Okay, so usually we see that up to 13.5 meter per second speed, we are getting maximum output of about 1000 watt. As we increase further, then still we see that the power output that is coming down. Okay, now vertical axis wind turbine. Till now what we have studied, that is horizontal axis. Why? Because the axis of the turbine, that is horizontal. Now in this case it is vertical. So here the drag is the main force in this type of turbine. Another thing, nacelle is placed at bottom. Means whatever we said that the system, power generating system that was on the top in the horizontal axis wind turbine, here it is at the bottom. The yaw mechanism is not required. We don't need to twist it, rotate it as per the wind direction. Then next is lower starting torque. Then difficulty in mounting the turbine and unwanted fluctuations in the power plant. So some of the features of this vertical axis wind turbine. Now comparing it with the horizontal axis wind turbine, which we studied in the beginning. So here lift is the main force. Drag is not there, lift is the main force. So cyclic stresses, that is less. And most commonly this type of horizontal axis turbine that is being used till up to approximately 95% of the turbines. They are this type of horizontal axis wind turbine. So nacelle that is placed at the top of the tower, okay, that we have seen in the construction and working point of view. Generator in the mechanism, that is all. Yaw mechanism that is required here. We need to twist or rotate or steer the upper part, the body, as per the wind direction. So height twice the blade length are found it economical. Means much height. The more the height, the better our wind turbine. And most commonly, most efficiently, 3 blade turbines, they are being used.